Hello students, today our topic is a diode resistance of a diode. We know the function of a diode. The main function of diode is allow the current in single direction, that is from positive to negative, or else diode allows the current in a single direction from high concentration region to low concentration region, which means what, whenever we use the diode, it will be controlling the current, so that the controlling the current means control the current means it is having a feature like resistor. You know already function of resistor to control the current. So diode is also controlling the current. So that is why diode is having some resistance. That resistance is called as resistance of a diode. So here this resistance, diode resistance, is two types: static resistance, static resistance, dynamic resistance, dynamic resistance. Diode is having two types of resistances: static resistance, dynamic resistance. So first we'll discuss about static resistance. Static resistance, again static resistance will be calculated in two types, again two types. We need to calculate this static resistance in forward bias as well as reverse bias. So static resistance calculated when diode is in forward bias condition and reverse bias condition. Dynamic resistance also calculated in forward when diode is in forward condition as well as reverse condition. So when diode is in forward bias condition, we need to calculate two types of resistances: static forward resistance, dynamic forward resistance. When diode is in reverse bias condition, we need to calculate two types of resistances: static reverse resistance, dynamic reverse resistance. Okay. So first we'll discuss about when diode is in forward bias condition. Diode is in forward bias condition. Okay, the resistance is a static forward resistance, dynamic forward resistance. When diode is in a forward bias condition, we need to calculate a static forward resistance, dynamic forward resistance. Okay, so first we'll discuss about this static forward resistance. So here static means static forward resistance definition is when diode is in DC condition. When diode is in DC condition, it offers some resistance. That resistance is called as static resistance. When diode is in DC condition, it offers some resistance. That resistance is called as static resistance. Here, when diode is in DC condition as well as diode is in forward bias condition, it offers some resistance. That total resistance is called as static forward resistance. Now coming to dynamic forward resistance. What is mean by dynamic forward resistance? When diode is in AC condition, when diode is in AC condition and when diode is in AC condition and forward bias, AC condition as well as in forward bias condition, it offers some resistance. That resistance is called as a dynamic forward resistance. Simply, what is mean by static? Static means static resistance means when diode is in DC condition, it offers some resistance. That resistance is called as static resistance. Dynamic resistance means when diode is in AC condition, it offers some resistance. That resistance is called as a dynamic forward resistance. Okay, so first, static forward resistance. What is mean by static forward resistance? The diode is in which condition? The diode is in which condition? Static forward resistance. So first type, static forward resistance. Static means when diode is in DC condition, it offers some resistance. That resistance is called as static resistance. Okay. So now diode is in DC condition. Diode is in DC condition means what? Biasing. We know already biasing, right? Biasing means giving an external voltage to diode is called as biasing. That is in two ways, right? So diode is in a, we can give the AC voltage or else DC voltage to diode, right? So AC voltage means AC current. AC voltage means alternating current. Alternating means always changing. And we can give DC voltage also. DC voltage means a constant voltage that is from battery connection. So we can give two types of voltages to diode, right? So that is AC and DC. Coming to static forward resistance, static will be calculated when diode is in DC condition only. When diode is in DC condition, it offers some resistance. That resistance is called as a static forward resistance. Then how to find the static forward resistance here? So here we need to take the VI characteristics of a diode when it is in forward bias condition. We know already the graph will be like this. This is the graph of VI characteristics when diode is in forward bias condition. Why I am taking forward characteristics here? Because this is the static resistance when diode is in forward condition, right? So that is why I am taking a forward characteristics graph. Okay, this is the graph. If a forward voltage is increases, current is also increasing. So now we need to calculate a static forward resistance. So static forward resistance indicating with a capital RF. We know the formula for resistance, normal formula for resistance, the ratio of voltage to current, right? The ratio of voltage to current. So here this voltage and current is in forward, diode is in forward condition. So that's why we are taking a forward voltage, forward current. The ratio of forward voltage to forward current is known as a resistance. Okay. So this is normal formula for static forward resistance. But we need to calculate this resistance from the graph. From the graph, what type of graph? Forward or reverse? This is the topic is about static forward resistance, right? So that is why I am taking forward characteristics. Okay. So here in this graph, I am taking one point. So this point is called as the operating point. So from this point, I am taking line on x-axis, and from this point, I am taking the line on y-axis. So here this is the origin. Simply I am taking one point on the graph. So from this point I am taking straight line to x-axis and straight line to y-axis. Okay, so on x-axis I am taking that A, on y-axis it will be indicating with the B. So from the graph we need to calculate static forward resistance. So after keeping this, now RF is equals to, RF means what? The ratio of voltage to current, the ratio of forward voltage to. So here we need to calculate for static forward resistance from the graph. We know already formula RF equals to ratio of forward voltage to forward current. So here from the graph, forward voltage is from origin, that is OA, divided by forward current. From the graph, forward current is OB. So, this is the formula of a static forward resistance from the graph. And this is the formula, normal formula. Without taking a graph, this is the formula, ratio of voltage, forward voltage to forward current. And this is the formula of a static forward resistance from the graph. And this is what about static forward resistance.